All right. So you guys have the 3, 3, and 3. You guys have the chapter 9 test tomorrow, and yeah, I'm still writing it. I'm feeling more conceptual than just crank through things. So here's a conceptual question. So you have this series, and I'm telling you this thing converges when x is 1. What does that tell you about these other places? Think about it. I don't have to be able to count. Any insight from anybody? Celia?
It only converges at the center, so the limit is infinity, but the center isn't negative. I mean, isn't 3, so.
So I'm telling you it converges when x is 1. Where is the center? Luke?
Maybe it converges when x is 5.
It maybe converges when x is 5. Well, this one is saying about converges conditionally. So again, where is the center? Eitan? The center's at 3. How do you know what the center is? Well, when that's 0. The center is at x equals 3. What does that mean? Gabriel.
The radius of convergence is 2.
Is it fine? Is it stuck at 2? Could it be bigger?
It's greater than or equal to 2.
Okay. Eitan, what were you going to say?
I was going to say it's within negative.
Okay. So centered here converges at 1. Do we know that it diverges at negative 2? Not really. Like, I don't know the radius is 2. I know the radius is at least 2. So does it diverge at 2? Always true, sometimes true, never true. Sometimes, could be. Does it converge when x is 2? Does it have to? Because if it converges from 3 down to 1, like that's what radius of convergence means, is it worked from here to that end, it's going to work for everybody in between. So that one's going to be, hell yeah, has to. If this stuff is true, that's true. Does it diverge when x is 6? Maybe. Eitan, what were you going to say?
I was going to say yes, because like isn't this like a geometric series?
It doesn't have to be geometric, because a sub n could be doing funny things, and the only thing I'm telling you about a sub n is it's always positive. So if a sub n has like an n factorial in the bottom, it's going to converge everywhere. So with that said, do I know that it diverges when x is 6, or I was thinking 5 and I wrote 4. If I go 2 units that way, 2 units to the other way, would it converge at 5? Does it have to? What if it's one of those endpoint things? Could it diverge? Maybe. Does it have to diverge? No. Converges conditionally. Is this one possible? No, why not?
Because it would be unconditional. Because it's equal to 2.
Because I'm telling you here, A sub n, always positive. That's not gonna alternate, so it's not gonna be conditional. Okay? All right, so lots of people had questions. So, questions on what? Brooke, you had questions on the sample test?
Yeah, but we probably. Hold on.
So, there is a lot in this chapter, and I can't ask you everything. This year was stressing, absolute versus conditional convergence. And sixth period asked yesterday very precise questions on for non-power series, what makes something conditionally versus absolutely convergent. So non-power series is just a string of numbers. Here's a string of numbers. Does it alternate? Yes. Do the terms get smaller and smaller? Yes. Does the last term go to 0? So with that, this converges by alternating series. Is it conditional or is it absolute? Well, if I did the absolute value, so made all these guys positives, now it does not pass the alternating series test. It looks kind of, it's not 1 over n, but it's 1 over n plus 2 or something. That diverges by p series, well, limit comparison and then p series. So that non-power series, so there's no x's in it, I'm ignoring what I started with, but the string of numbers converges conditionally, not absolutely, because if I did the absolute value, it no longer works. If I had this, terms get smaller and smaller, it alternates, and the last term goes to 0. If I did the absolute value of it, it would also converge because this is 1 over n squared, and that converges by p series. So sometimes you can converge by alternating series, but also something else that we knew before.
If the series is not alternating, do you still have to check?
Check alternating series
Check
test.
if it's absolute.
In general, the ones that are going to be conditional or because of the alternating. Like I don't know off the top of my head right this second that there is a way for it to converge without alternating. However, this one was hidden. I didn't make it an obvious -1 to the power. I made you do the sign thing to see that the sign turned on and off. Okay, anything from homework or old tests and stuff? Yeah.
Could you just do like the next question and they said E? So I tried doing just like the limit comparison, but I'm not sure.
Okay. So real quick, by power, checking the powers, it looks like this is gonna converge. So it alternates, the last term goes to 0 and the terms get smaller and smaller, so it does converge by alternating series. But then the rest of it, looking at just the powers, that looks like 1 over n to the 7/2, which that power is bigger than 1, so it's going to converge by p series. Do the limit comparison, the two functions go to infinity at the same rate. And this one converges by p series, so they both converge. It did not need to alternate, so it converges absolutely as well.
Okay, so you did like the first one to see if it converges like period, and the
If-
second one is like if it does, absolutely.
Yes.
I think it was number 4 in part C where it asks us about like the Lagrange error. I don't know if it's part C or this thing.
This was
But yeah, number 3. For the closed interval, like I know you're evaluating it at f0, but how do you know what's a bit for descent, like as it goes down?
To find where the, okay,
Yeah, so first ignore term, because I know it's like 11 times whatever to the 4th power of 4.
the fourth derivative, they're telling you this notation, you guys hate it, I don't know why, it's them being nice. It's telling you the fourth derivative in the interval that we're concerned about, the biggest that's gonna be is an 11. So just take the 11 and go with it. Okay, you still have the question though. All right. First of all, looking at the quizzes, some of you still not comfortable with this Taylor polynomial stuff. The polynomial at the center equals the function at the center. This is not the first derivative, or sorry, there is no first derivative. The first derivative is 0 because I don't have an x to the first term. But -3 is not the value of the second derivative. Any given term, that f derivative at the center times x minus the center to the nth power over n factorial. That's what this guy equals. So -3 over 2 factorial equals, or sorry, f double prime of 2 over 2 factorial equals that -3. That was on the quiz, and some of you only needed the sign, like is it positive or negative, to make some conclusions, but some of you were like, yeah, it's -3. I'm like, no, it's not. Which, this was on the quiz. I asked, is there a max min there? And this first derivative was 0, so it had a critical point. The second derivative was negative, so it was concave down, so that critical point where it was, that was a maximum. Okay, so you asked about this part.
Yeah, like I understand how you get the 11 over 4 factorial and like 2 to the 4th power, like I get that, and I understand like x minus c, you're evaluating or approximating x, which is 0 in this case. But then -2, for the interval, why would you choose?
Where's the center of this equation?
Isn't it 0 to 2? So then wouldn't it be
Where's the center? Center is one specific place, looking at the polynomial they gave us.
Oh, 2, okay.
And what makes, so from the center down to 0, what makes this, pick any number at all in this interval, what makes that biggest value the other endpoint? So 0 minus 2. And it ended up to the 4th power, but even if this came out as a negative, error is always a positive, and you're like, oh, it's plus or minus this amount. Other questions from the test or from the homework or stuff?
Yeah. Can you go over how to simplify factorial?
Sure. Oh, I don't want the +3. So if it's a complicated one that you needed to do some stuff, I totally messed this up. Two should not be inside. So 2 times n plus 1 times n times n minus 1 times n minus 2 times, and run out of room, so n minus 3 on down, over n times n minus 1 times n minus 2 times, run out of room again. Did I need to spell all of those out, or could I have just left it as n factorial? Um, Any questions for 9.5, 9.3? 9.3 is error, 9.5 is testing endpoints, 9.4 was ratio test. You guys okay with setting up ratio test? Ari, what does it mean if my ratio test comes out and I get infinity?
It looks for,
The word for everything.
Here's what I.
Okay, so let's think about it again. This is, I have a set of terms. 1 plus, I don't know. If I take the next one down the line and divide by the previous one, I get the thing I'm multiplying by, right? So I'm taking the next one down the line over the current one. I am multiplying by infinity each time when I get to the next term. Is that gonna converge for everything? No, it's not. Like, this is the, only converges at the center. And like this one. This is gonna be infinity times that thing. It's gonna converge only when x is 7. This one I didn't put an x in there, so maybe it just doesn't converge, it just gets huge. String of numbers. So Arabella, what does it mean if the ratio test gives me a 0? No, Preston, what's the value when ratio test gives us this particular value, we gotta do something else?
That's nice.
1. So if the ratio test gives you a 1, it's a bad test. But thinking about this again, this is effectively at the end of time, I'm multiplying by 0 to get each new term. For so any x value you chose, it's gonna work. And Hannah, what do I need to do with this one? The last one?
Yeah, I will put it in the essay note.
So that, and you guys still a bit allergic to that. Miriam, pick a number. Jamie, pick a number.
6.
Jasper, pick a number. Solve for the radius that would make that thing converge. Amber, what's the first step?
You multiply by, or you have to like take away the absolute value bars and make it like -1, staying in the middle, 2.
Okay, first step, alligator, -1 to 1. Some of you don't do that step, and you multiply by the 7 and then drop the bars, and I found half of you that did that never put the left side back. Sean, what do we do?
What, by 7 right now?
Multiply all the pieces by 7. So -7 less than 3x minus 6, which is less than 7. All right, Brady, what now?
Add 6 to both sides.
Add 6 to all the sides, there's 3 of them. Massimo, what now?
Divide everything by 3.
All the pieces divide by 3. Okay, unpleasant, but there it is. And if this was something that we got out of ratio test, I would now check each term with that x value to see if that individual string of numbers comes out. Question?
If you do the ratio test and get 1, what do you do instead?
Pick a different test. Limit comparison, P series, 10 term test, something. You only have to check the influence from the ratio test. So when a question asks you, what's the radius of convergence? That's ratio test. And if you get X stuff that spits out, test those ends to know to check if it's a square bracket or an open bracket. Can we use nth term test to prove that something converges?
No, right?
No, why not?
I don't remember actually.
I don't remember, just kill you.
If the limit doesn't equal 0, then it like diverges. But if it equals 0, then it's inconclusive.
I mean, nth term test, if you're adding bigger and bigger numbers or anything of substance, can you ever contain that problem? Can you ever like get a final number? No, it's just gonna get bigger and bigger. So this, the limit as n goes to infinity of n, well, it's gonna be a permanent big problem. This one, as n over n plus 1 goes to infinity, that nth term, the last term, it's only one, but it's forever adding one more thing. It's one more thing, one more thing, one more paper to grade. Oh my God, one more paper that never go away. By the nth term test, you're never going to finish the grading ever, ever. Love that for me. Cool. Sorry, venting. It's a Wednesday. Okay. Other questions before I go off my own? Yeah.
For the, like with the nth term test, can you use it for like power series to like find the like thing you should do for the angle of convergence?
Yeah, you can use it for all the things. I mean, this is a non-power series, first of all, but this is, I would say, diverges by geometric. Straight up, the thing I'm multiplying by is bigger than 1. That now, things are going to get bigger and bigger unless I choose x very carefully, and that will converge when x is -3 and at no other place.
So if we could like use the like nth term test and then like say that it equals x plus 3 and then put that into the interval, or would we just have to?
I would do with power series, do the ratio test first and then check stuff.
Okay.
But, yeah. Did we do this one before, already? Did it in one class? I don't know. Does that converge or diverge?
If it's anything other than zero, it's implicitly saying divergent. And I say that if it's not zero, because there's one or two yesterday that you did that.
Oh, yeah.
Either it's a positive one or a negative one, positive one or a negative one. So I can't tell you what's limited, but I can tell you what.
Okay.
Yeah.
Just not like.
Yeah, but I just
You
don't have to do that.
I know.
That's what I.
The like limit
I'm trying to do margin, and I don't know, like, I never know what to do.
Do I have X's in this series, or is it a non-power series that gives me a string of numbers? Non-power, no X's, just a string of numbers. Alex seems to feel that this would fit nicely with a P-series limit comparison test. So he's doing unconventionally the upside down of the thing he's
Same
comparing to.
idea.
Normally I put the reciprocal second, so it's obvious that I'm divided by, but all good. Variations are permitted. Free thinkers, you guys are going to be the creative engineers of the future. Uh-huh, writing.
I hate this.
I know you guys do, all of you do. Try grading it with questionable handwriting and grammar. Like, infinity, no A in that word, by the way. Every now and then I fail to help to fix your spelling. It's not infinitely. And in geometry, students writing out the word beta. Beta begins with a TH. They're writing feta. Really? Not that writing? So, so feta.
Like on Google, I was trying to look up like the symbol. And like feta cheese kept popping up. Couldn't figure out.
Okay, so what do you think? It says the limit of these two things went to one.
I can't pronounce it. Yeah, because like theta sounds like yeah. Like I feel like theta like I don't know. I don't know.
Okay, ready? Okay, this is not direct comparison, this is limit comparison. And what he did was he divided this and then multiplied by that, which is technically comes out to finding one function over the other. This became n squared over n squared plus 1. If those were x's, and I asked you in pre-cal last year, where's the horizontal asymptote of this rational function, you would have told me 1. The point of using limit comparison versus direct comparison at plus 1, I can just roll right over it because at infinity it doesn't matter. Direct comparison, it messes everything up. Okay, so example where direct comparison is needed. I don't know, 17 looks like a good number today. Clara, 1, 2, or 3? 3. So there, I cannot use limit comparison. Because where's the limit of that going? That sine x up top makes, well, actually, let's go to something. I don't know. That didn't change things. But the sine x up top, if I try to do limit comparison, one function over the other, the sign doesn't resolve itself. So, by instinct, is this going to converge or diverge? Converge because the denominator is a cubed. There's no ends up top. So the cubed by p-series is going to converge. So now I need a function for direct comparison. Do I need one that's underneath going to lift it up, or one that's on top and squish it down? One that's bigger. And it needs to be completely bigger or equal. Can I pick this? No, why not, Nick?
It's not bigger.
It's not bigger for all of that, because sine.
Sine is add 1.
Okay, so you said add 1. That is always and forever above or equal to this. And the reason direct comparison is scary, it is because I said so. Damn it. Damn it button, it just is. Believe me, respect my authority. And the reason we picked this one is you guys said it was going to converge. So then they both converge. Yeah.
Could you do direct comparison with 19
P plus one and then do the comparison for rent P plus one.
Makes it much more complicated and add another test again.
When you have to say like it's absolutely conditional.
They ask absolute convergence, like the sample test. It said, okay, first of all, does it converge? And then does it converge absolutely? And Nina asked about it too. If it doesn't alternate, there's nothing conditional. Yeah, so if you had to use alternating series tests to say that it converged, and it doesn't work any other way, that's conditionally convergent.
This is unrelated to this, but it's like
Okay.
a sample test. There was like a problem where I think it was asking if it was like converging or diverging. It was number 4. And I did like the ratio test to keep going, but then I got to a point where it was like the limit as n approaches infinity is x plus 1 over n plus 1.
Uh-huh.
Oh yeah. Was that okay? Yeah, I was
So-
wondering.
This is, okay, here, x is a variable, but not really. I would be like, Kai, pick a number, and he says,
3.
3. 3. 3 plus 1. He picked a number. So once you pick a number, his static finite number, whatever it is, maybe it was 3 Googleplexes, which is a Google to a Google. I'm dividing by infinity. I'm not finite. Infinity plus 1. His finite number divided by infinity will eventually be 0. He could have picked any x number. I'm going to obliterate it eventually.
Okay, so you don't have to like keep the x plus 1. It's just like as if it's a finite.
Great. Sydney?
So x couldn't be infinity because it has to be like
You have to pick a number. Pick a number, any number. 3,542, whatever. He had to pick a number that he could say and write down without the symbol, no alternates. So this one, any x he picked, he had to pick something. And eventually my infinity is going to overcome. Then there's this kind that doing the ratio test. This one's the pain. All right, I got ends. This pre-cal happened, that stuff goes to 1, and I get out that x plus 3. Check each endpoint. Okay, well, testing the endpoint for -4, that's saying I picked that x value of -4. Plugging -4 in, -4 plus 3 is -1. Yay. It alternates, terms get smaller, the last term goes to 0. This guy converges by alternating series test. Putting in the -2, or sorry, I should say -2, why did it say Okay. Plugging in the other endpoint becomes 1 over the square root of stuff. It's no longer alternating. That's going to diverge by p series. Yeah.
If it asks for it, would you say that this is conditional convergence? Because it's a
This is conditionally, and really, if one end is included and the other end is not, there was some condition that was cool for this guy that didn't work for that guy, so it's conditional. If they were both open, it's like, forget it, neither one of you were invited. Or if they were both closed, we're all accepting of everybody. Both of you were allowed, there was no special exceptions.
Isn't technically the -1 over n to the 1/2, would that also technically IP series diverge, or you just do they
This is -1 to the end, so it's positive, negative, positive, negative, positive, negative.
Yeah.
So in that parting the C's things, A for alternating series test, if all 3 of these things are true, that is a special exception that will make the P series stuff suddenly work because you're overcorrecting, like, I'm too far this way, and I counteract it by going too far to the left. A little bit less to the right, a little bit. And so if you're bouncing back and getting closer and closer to your answer, then it's gonna converge.
Gotcha.
Yep. The only thing to the alternating series test is to know that it exists and has these three conditions. Was there a 6? I don't know if they, yes. So this one, when it's strictly geometric, the ends are not gonna work, but it's always good to check them anyway. And it should not have worked. Did I do it wrong? Actually, this is Mr. Orlando's handwriting. Question? Sure.
Do you have to say it's like geometric with that ratio,
No.
or can you just go straight to the?
You can go straight to, they don't need to write this stuff. Grady?
When I did before, I got 4 minus 1 over 3 equals 0, 3, 1 to the end. And I got,
This?
yeah.
What about,
No, I got 3 over 3 to the end instead of 1 over 3 to the end.
yeah, I was gonna say this shouldn't work. So plugging in the 4. It's 3 to the end over 3 to the end, so we're adding up. Does that converge? Why not? What's the name of the official test? Nth term test. The last dude is not 0, so it's not gonna pass.
So if it's geometric, do we even have to check that?
No, which is why I was kind of surprised that it had an inclusion point. I'm like, it's not allowed. Fiona?
I have a question. It's also not related to this. I have
Okay.
a question about like the notation for the error problem. Like when it says like f number
Derivative.
x, does that mean like the sum of like all the things up to that derivative? Like if it was 4, like this.
It just means the nth derivative, if that was a 4 or 5 or 17, 17th derivative evaluated at that is less than 12, whatever. Doesn't mean all of them added up, just means that
Oh, it
derivative.
just means the derivative. Does it include, because it's like f of x, does it include like if it were like x minus 2 to the 17?
You need to put that stuff on. Sorry, there was another question on this? No? Different question?
Yeah, it was for 7.
Okay, this is one of those multiple choice kind of questions. I would list things out. So. That's my Taylor series. Find f prime. That guy goes away, and then I end up with and then look for the one that meets the pattern. All the x's are gonna end up going away, so it's 1 ace of 1, 2 ace of 2, 3 ace of 3. So it looks like a n ace of n, and then you got a match.